Welcome back. We're going to continue our discussion on organic chemical reactions. In the previous video or set of video series, we looked at one particular type of chemical reaction that's free radical. You were wondering, why did I sign up for the class? Yes, it's a little bit tricky, but not hard. Trust me, it's not hard compared to any other class that you may be in, any other content. That's not hard at all. Yes, it may be a 4 out of 10 and maybe a little tricky once you do a few practice problems in class. It's under control. In fact, you might even think, oh, why do I not have more of this on the exam? Down the road, but not right now. But the next class of reactions we're going to look at are addition reactions. And the rationale behind the way I'm doing it the way right now is based on the curriculum I've developed. But also, first, we want to know how to go between all the different functional groups we've learned in naming. We want to go between alkanes, alkenes, aldehydes, ketones. We want to know how we can go from one to the other so you can see the relationship between the two. Later down the course in this semester and next semester, we're going to pick some of these and analyze more deeply so that we can develop lab experiments pertaining to that, so all of that makes sense. All right, enough with the rant. Let's keep moving. As I said, these are part of a class of compound called addition reactions. What did I say? Addition reactions. Okay, and there's two primary kinds. One is Markovnikovs, and the other is anti-Markovnikovs. Okay, and again, we're synthesizing alkyl halides. If you see a trend, we synthesized alkyl halides from alkanes and then from alkenes, but both from a free radical perspective. This is sort of along the same line, but we're going to call it addition reaction for now. And then we're producing them from alkenes, but if you notice, we're neither using Br2 nor using NBS, okay, which is N-bromosuccinimide. So when you are given a molecule and you're adding HBr to it, the hydrogen gets added to the less substituted carbon. What do I mean by more substituted carbon and less? We'll get to that in just a second. This is very easy stuff. Gets added to the more substituted carbon. You'd wonder, oh, wow, this is all there is? Well, that's all there is to it once I finish explaining it. So if you look at the molecule, we're only focusing on the carbons containing the double bond. So it's this. And this statement only applies to the carbons that are involved in the double bond. Keep in mind, we're synthesizing alkyl halides from alkenes. So what's in the rest of the molecule doesn't even matter. So let's rewrite this molecule. Okay. Now, this is why I had you learn Z and E, and in the process, I kept reminding you about the importance of hydrogens. Now, if you write the two carbons, this carbon contains a methyl and then this substituent. This carbon contains this and the hydrogen. Okay. In this compound, in this reaction and the one following it, I'm going to record it in the same video because there's no reason for them to be two separate videos. In fact, they work together and works better and contrast each other if they're in the same video. Okay. So the carbon containing the hydrogen is the less substituted. All you have to do is figure out which side has the hydrogen. And the side that doesn't have the hydrogen is the more substituted carbon. Again, we're only interested in the two carbon that's containing the double bond. So it's this carbon and this carbon. This carbon contains a hydrogen, so it's less substituted. This contains more substituted. So when we write the product, we write everything the same minus the double bond. Okay. For now, don't worry about, the stereochemistry. We will get to that later. But for now, write the hydrogen on the side that's less substituted and the Br on the side that's more substituted. Less substituted means the carbon containing the hydrogen. So I'm going to write this, which means carbon containing the hydrogen. So the H from the HBr gets added to the less substituted carbon. A less substituted carbon is the carbon containing the hydrogen, and Br gets added to the more substituted carbon, that is the carbon with no hydrogen. Okay. Well, if you don't have a hydrogen to start with, I'm not really sure how that works. Okay. I don't think you can even have this. So this is Markovnikov. So this is what we have added. We've added the hydrogen to the less substituted carbon, which is the carbon containing the hydrogen, and the Br to the carbon containing no hydrogen or the more substituted carbon. This is Markovnikov's. So why don't you name it? So this is simply nothing but this. I want you to name this as part of your practice. Okay, so name the compound. We've learned naming extensively, so you should be able to do this. All right, and I don't have to always draw without the hydrogens. You should be able to do this yourself as well. So let's look at its counterpart. That's anti-Markovnikov's. Again, we have the same exact compound. We have the HBr, but we have something called hydrogen peroxide. That's H2O2. Okay, the rule is opposite. The HBr, right? The hydrogen gets added to the, can you complete the statement? Yeah, gets added to the more substituted carbon. This is something so easy, but I still see one or two people on the exam, they mix it up between Markovnikov's. There's no reason to. Br gets added to the less substituted carbon. And what did we mean by less substituted and more substituted? More substituted means the carbon contains no hydrogen, and less substituted means the carbon contains one hydrogen. Okay, one or two, but usually one. Okay, so let's redraw this molecule. It's the same exact molecule from the previous case. This is the one with the hydrogen. This is the one without the hydrogen. So this is less substituted. I'm trying my best to explain this concept in the simplest of the form possible. More substituted. Now this is with the hydrogen peroxide, so it's anti-Markovnikov, so it's the other way around. So the Br gets added to the hydrogen compound, carbon containing the hydrogen, and then the hydrogen gets added to the carbon containing the no hydrogen. So if we draw this back, basically this is what the molecule is, right? And again, I want you to name the compound. So the key here is not naming. I don't want you to think that that is the purpose of the video. The purpose is to show you the difference between Markovnikov's. This is Markovnikov's, and this is anti-Markovnikov's. You see the Br is switch places and the hydrogen switch places as well. And I want you to name the compound, okay, in both cases. So that'll be the part of the practice. I can give you a more practice problem itself, but this is all there is. It's such an easy concept. There's no reason for me to give you 10,000 problems to practice. All you have to know is when is Markovnikov's, when is anti-Markovnikov. Markovnikov's doesn't contain peroxide. Anti-Markovnikov's contains hydrogen peroxide, and you have to know the rules for that. I will not give that rule on the back of the test. All right, so stay tuned for more reactions.